In section 6.3b, we're going to go over how to divide polynomials using synthetic division. Now, synthetic division is just a quick way to divide a polynomial by a binomial. We're just going to cross this part out here and just say all the variables are taken out. Now, synthetic division is so much faster and so much easier than long division. The only problem is you can't use it for every type of problem. So there were several questions on yesterday's homework you would not be able to use it on. The only time you can use synthetic division is if you are dividing by a binomial. Remember, binomial means two terms of degree 1. So, for instance, if you are dividing by x plus 1, you can use synthetic division. If you are dividing by x squared plus 1, you can't use synthetic division. If you are dividing by 2x plus 1, you can't use synthetic division. The reason why you can't use this one is because this is not degree 1. The reason why you can't use this one is because the lead coefficient is not 1. So the lead coefficient also has to be 1. So here we have the lead coefficient of 1. Here we have a degree of 1. Okay, here's just an example of long division and some of the terminology. This would be the divisor. Look, what you get after you divide is the quotient, and what you divide into is the dividend, and of course down here is your remainder. All right, now we're not going to use all of the instructions here. We're just going to use, we're going to work them out, but we're not going to fill in all the blanks. The first thing that we need to do is put the dividend. So this is your dividend. Slide down here. This is your dividend. So this is our dividend right here. We need to put that in standard form. So we're going to write standard form, and then we're going to put zeros in for placeholders for any missing terms. Okay, now we're going to cross these off. We're going to just work the problem out over here. Okay, so we need to put the dividend in standard form, so that means the highest exponent goes first. So as we do this, we're going to take out all of the variables. That's why the exponents are so important, because the location of the number determines what the exponent on the variable is. So as we write this, we have 2y cubed, so we're just going to write 2. So that's, I'm going to write the degrees up here. This is degree 3. Then we go to degree 2. That would be minus 1. Degree 1 we don't have, but we need to put a placeholder in there to the first degree. So we're going to put a 0 in here, and then we're going to write the 25. So this is in standard form. Here's our 0 for placeholder for a degree of 1. And then we're going to take what we're dividing by. And remember, this has to be a degree of 1 and a coefficient of 1. If that's the case, we take the opposite of this. And we're just going to make a little backwards L here. And we're going to take the opposite of this and put it in here. The next thing that we're going to do is we're going to skip a line. We'll draw a line, and then we're going to put a vertical bar right between the last two numbers. This is where our remainder is going to go. Okay, and then we're going to draw an arrow and drop this very first one straight down. So that's going to be a 2 here. Okay, so that's the setup before we start doing any division. So we're going to write the dividend in standard form. So exponents going down by 1. If they're missing a degree, we fill it in with a 0. Then we look at the divisor, what we're dividing by, and we take the opposite of this term number right here. So that would be positive 3. We put it in that backwards L. We skip a line, draw a line, and put a spot here for the remainder. Remainder is going to be right in here. And then we drop this first 2. After we have that set up, everything is just going to be multiplying and adding. So if it's down here, we're going to multiply by this number here. So 2 times 3 is going to give us 6. That goes right here. After we have the 6 above the line, we're going to add, and that's 5. Once we come down here, we multiply again. So 5 times 3 is 15, and then we're going to add. And once it's down here, we multiply. 15 times 3 is 45. And then we add. So that's going to give us 70. Now we need our answers to look like they did yesterday. So we need to put the variables back in. We took them out. Now we need to put them back in. And so we're going to say, look at our degree. Our highest degree was 3. Now because we're dividing by y, the degree has to be 1 less here. So if this was cubed, this one's going to be squared. And then we go down by 1. So squared to the first, and then our constant. And this is our remainder. So let's rewrite this as an answer. It's going to be 2x squared plus 5x plus 15 plus 70 over, just like what we did with long division, the divisor here. So that's going to be y minus 3. Okay, now I'd like to show you that it works out the same with long division. So let's do long division here. We'll say y minus 3 gets divided into 2y cubed minus y squared plus 0y plus 25. Okay, so we ask ourselves, how many times does y go into 2y cubed? So 2y cubed divided by y is going to give us 2y squared. So 2y squared. And I can use, here I changed the y's to x's. That's okay. I just went back to y's here. So we have 2y cubed. And when I'm multiplying, I have to multiply the whole thing. So this is going to be negative 6y squared. I'm going to change my signs and then add. So this is 5y squared. I'll bring down the 0y. And I start all over again. So 5y squared divided by y is going to give me 5y. That's going to go up here. And then I do 5y times y, so that's 5y squared. Multiply this, minus 15y. Change my signs. Oops, that doesn't look like a plus there. And add. So this is going to be 15y. I'll bring down the 25. And same thing again. 15y divided by y is going to be plus 15. So 15 times y is 15y. And then minus 45. I'll change my signs and add. So that's going to be 70. My remainder is going to be plus 70 over y minus 3. So same answer. Oops, I think I should have had this be an x here. So let's change that to an x. Again, you can use whatever variable you want here. When I was rewriting, I used x instead of y, so I need an x here. But anyway, the same coefficient. So we have 2 here, we have a plus 5, we have a 15, and we have a 70. Okay, let's try one more. On the You Try It section, I'll have you do this one here, and we'll do this one together. And we need to make this one be in standard form. So this should go degree 4, 3, 2, 1, and 0. Okay, so we're going to take out the variables. So degree of 4, the coefficient is 3. Degree of 3, we have a negative 1. Degree of 2, we don't have. Degree of 1, coefficient is 5. And then we have the constant, which is negative 1. Draw a line here. Spot for the remainder in between the last two numbers. Put a backwards L up here. We take the opposite of this, which is minus 2. Alright, and then we're going to drop this down, which is 3. And we're going to multiply and add. So this is going to be negative 6. Add, we get negative 7. Multiply, we get 14. Add, we get 14. Multiply, we get negative 28. Add, we get negative 23. Multiply, we get 46. Add, we get 45. Okay, so we started with a degree of 4. We divided by an x, so that means it would be x cubed. So we're going to put the x cubed here, and then it's going to go x squared, 14x, and minus 23. So when we write the final answer, it's going to be 3x cubed minus 7x squared plus 14x minus 23. And then we take the remainder and put it over x plus 2. Okay, you can do the other You Try It.